Hi, fifth period awesome people. I'm going to go through the notes that we did in class today, and I'm also going to go through the practice problem, that the very first practice problem. I'm probably going to split these up into a couple of different videos for you because I think it'll be easier that way. So we're gonna tackle that right now. So the first thing that we talked about is that we know that Jupiter and Earth are in the same system. Because they are in the same system, we know that Ke is equal to 1, Kj is equal to 1, right? So what we could say about that is that the constant for Earth is equal to the constant for Jupiter. And this is the constant that we're looking at within the law of harmonies. Because Ke equals Te squared over Re squared, we can substitute that in for K because they're equivalent. We can do the same thing with Jupiter. That's cubed down there on the bottom. Okay, so Te squared over Re cubed is equal to Tj squared over Rj cubed. So we can set it up this way, but on Friday we went through the whole process to get to what is usually used as Kepler's third law, which is Te over Tj whole quantity squared equals Re over Rj whole quantity cubed. There's nothing wrong with this. You can still use this, but this is the typical format that's used. And this is the format that I'll go through. So I'm going to give you some problems here, or I'm going to give you some information for our problem. So I'm going to give you the givens for this problem, and that is that Re is equal to 1.5 times 10 to the 8th meters, and Rj is equal to 7.8 times 10 to the 8th meters. Okay. I'm also going to tell you that Te is equal to 1 year, and we want to find what Tj is. So that is our unknown for this particular setup. So what equation are we going to use? We're going to use Te over Tj squared equals Re over Rj cubed. Okay. So then we'll start going through the steps to solve this. So here we go with the solve. So the first thing I'll do is put information into the equation. So I'll plug in. So that would be that Te is equal to 1 year. And we don't know what Tj is. And we're going to square all of that. Equals Re, which is 1.5 times 10 to the 8th meters, over Rj, which is 7.8 times 10 to the 8th meters. And that whole value is cubed. Okay, so first thing that I'll do here is I'll do the math inside this. So I have 1 year over Tj, all of that squared, haven't done anything to it. And then over here I get 0.1923, and that whole quantity is cubed. If you notice, there are no units here, and that's because if there's a unit on top and a unit on the bottom, those cancel out. When they cancel out, there's no unit left here. Now I want to do the parentheses. So I'm going to do what's outside the parentheses. I'm going to do my exponents. And so 1 squared is 1. A year squared is a year squared. Tj squared is TJ squared. And then to square this number, I get to cube this number, I get 7.112 times 10 to the negative third. So it really would give me 0.007112, but I want to write it in scientific notation. So I'm going to move that decimal place over 3 spots, and that's where I get the negative 3, because it's 0.007112. Move the decimal place over 7.112 times 10 to the negative third. Those are equivalent numbers. All right, now I need to get the TJ out of the denominator here. So the TJ is sitting down here in the denominator. That's not going to help me in solving. I have to get it into the numerator, or I really have to get it beside itself, or on a side by itself. So I'm going to say TJ squared here, multiply that side by TJ squared, multiply this side by TJ squared. So that allows me to get rid of this canceling, and that'll just sit over there. So now I'll have 1 year squared equals 7.112 times 10 to the negative third times TJ squared. Well, I've still got to get that TJ squared by itself. So in order to do that, I'm going to divide by 7.112 times 10 to the negative third. If I do that to one side, I have to do it to the other. And so over here, those cancel. And I wind up with TJ squared is equal to 1 year squared over 7.112 times 10 to the negative third. When I do that math, this works out to 1.406 times 10 to the second years squared equals TJ squared. So at this point in time, I need to find just TJ. I have TJ squared. The way that I find that is I find the square root of this side. I can do anything over here as long as I do it over here to this side. So I'm going to find the square root of all of that. So what I find is that I get 1.186 times 10 to the first years, because I'm also finding the square root of the years squared, equals TJ. So now this is no longer squared because I found the square root of it. Square root means basically finding what it is that you have to multiply by itself in order to get whatever term you have here. This is pretty small for scientific notation, so I'll just switch it back. So I'm going to move, this tells me I need to, if I want to switch it back, I'm going to move the decimal place 1 over. So I'll have 1.86 years. So 11.86 years. Okay. And that is our answer right there. You can also see the annotated version of this in the notes.